Hello students, welcome back to OrganiChemVerse. Today I'm back with one more JEE advanced level question. First let's understand what is the question here. There is a dihaloorganic compound. It is treated with aqueous KOH followed by CrO3 in acidic medium. That means this is an oxidizing agent, right? The moment you look at these, you need to know what sort of reactions they are undergoing, right? And then acidification. So what will be the final product? Before you start writing the reactions, just look at the options given here. You see the products are cyclized products. That means what? This is undergoing cyclization. So based on that, you have to predict the products. At first, when we add aqueous KOH, the molecule is supposed to undergo nucleophilic substitution reaction. So what does that mean? The KOH provides a nucleophile, that is hydroxide ion, and it's supposed to attack the carbon where there is a leaving group. This OH can either attack on this carbon or on this carbon. But remember that whenever we have a haloarene, right, the halogen, because of the lone pair of electron, will undergo resonance with the benzene ring. Because of this, you will see there is a partial double bond and it becomes very difficult to break this double bond. Hence, the attack of OH minus on this carbon is not possible or it's forbidden. That means what? This bromine on the benzene ring, that is haloarene, will be as it is. So look at the options. In option A and D, the bromine is intact. Therefore, the answer has to be either A or D. You can easily eliminate option B and C now. Now, when the OH minus attacks this carbon and the bromine is being eliminated, what product you can expect? You see, this bromine is intact. At meta position, we have the alkyl chain, right? Now the OH minus supposed to attack. So when it attacks, the bromine will leave and hence you're going to get a product something like this. See, I'm going to write the product slightly in a different way because ultimately you're going to cyclize this, right? That's the reason. So you see here, 1, 2, 3 carbons are there. This is where the OH is present, right? And then what happens? You are having an acidic medium here, right? So CrO3H plus. So that means what? The oxygen will get protonated, right? So it will become oxygen with a positive charge. So ultimately, it will be removed as water. But which carbon is supposed to attack this carbon now, right? In order to remove this OH. So bromine is a ortho para directing group. So this is ortho, this is meta, and this is para. So will this attack ortho position or para position? See, bromine is a bulky atom. So therefore what happens? There is a steric hindrance at the ortho position. So it prefers to go to the para position. So when it goes to para position, you see the water will be eliminated as I was telling earlier. So now the bromine is as it is and we have 3 carbons. So 1, 2, 3. So 1, 2, 3 and then we are going to get a 5-membered ring. So since 5-membered rings are quite stable, that's why this reaction is possible, right? Then what happens? There is an oxidizing agent, right? So CrO3 in acidic medium is quite a strong oxidizing agent. So usually it produces carboxylic acids, but in this case, right, it's going to form a ketone as it is a cyclic, right? And where it happens, it usually happens at the benzylic position. That means where it is attached to the benzene carbon, right? So here, so that means what? The oxidation is going to takes place at the, so it's supposed to be 5-membered and here, right, like this. So and where do we have this? We have it in option A. Therefore the right option is A. Students, I'm going to give you one more trick. Without writing all these reactions, you can directly predict the product. How so? So first thing is you are intact, you are keeping the bromine intact, right? So it has to be either B or D. Then it has to go to para position because bromine is a sterically hindered atom, right? So that means it's forming steric hindrance at the ortho position. So para to this is this. So this is where the cyclization should happen. So look at option A and D. So here it is ortho. So steric hindrance is more. Hence, the right option is option A. So that would take hardly 1 to 2 minutes. I hope I made this clear. If you still have any doubts, you can comment them in the comment box. Thank you.